Welcome to the Math Record. This video would be the second part of the ICTM Regional 2019 Division AA Junior Senior 8-person. In this video, I'll be answering questions 17, 18, and 19. Okay, 17. So in a 12-hour clock, the display on a digital clock is a arithmetic sequence several times. Determine the number of k of such displays. So there's k amount of arithmetic sequence. Okay, and they say in this note that if it's the same number, it's a arithmetic sequence, but if it's only two of them, there's only two terms, then it's not. The display can also be a geometric sequence, so it could also be a geometric, and there's w amount of that. So then we have k plus w. Okay, so let's first find the arithmetic sequence. So in a digital clock, there is 10 digits, 10 single digits. It's 1, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's try to write our arithmetic sum. So it could be 0, 1, 2, 0, 2, 4, 0, 3, 6, 0, 4, 8, and then 0, 5, 10, which 10 is a double digit, so we stop. So after 0, we have 1, 1, 1, because that's the same thing. And we can't have 0, 0, 0 because it's technically not a thing. So, and then we have 1, 1, 1, right? And then we have 1, 2, 3, 1, 3, 5, 1, 4, 7, and 1, 5, 9. Okay, we stop there because 9 is the biggest. So the next one is 2, 2, 2, 2, 3, 4, 2, 4, 6, 2, 5, and 8. And then the next one will be 2, 6, 10. So that's not possible, so we stop there. And after that, we have 3, 3, 3, 3, 4, 5, 3, 5, 7, and 3, 6, and 9. So we stop there because that's a 9. And then we have 4, 4, 4, 4, 5, 6. And then for 6, then this would be an 8, 4, 6, 8, right? And then next one will be 4, 7, 10. So we have to stop there. And then we have 5, 5, 5, and then 5. And then anything after that kind of doesn't make sense because of 5, 6, 7. There's no like a time in that's 5, like 6, 7 p.m. or a.m., right? So this doesn't make sense. So any combinations after this doesn't make sense. Okay, so we don't have to list them anymore. So now let's just eliminate some combinations. So we know that when we have a time that's like 160, like 8 or something, 169, 165, right? It doesn't exist because 60 minutes is the max. So anything that's in the middle, that's a 6, we could get rid of. So we could get rid of this one and we could get rid of this one. Okay, so now let's count how many possibilities are in here. So this is only when there's a 3-digit, right? So you can't have a 0, 1, 2 because it can't just be 12 minutes. It has to be some kind of time. And this is also the reason why I didn't write 2, like 2, 1, 0. And that's because this is 2, 1, 0, right? You could just look backwards. So these are all the possible combinations. So it's either forwards or backwards, right? So it can't be this way. So you can only read backwards. So there's one here, and one here. So this one has 4 possibilities. Now 1, 1 is the same forwards and backwards, so there's only one possibility. 3, 2, 1, and then 1, 2, 3, 1, 3, 5, 5, 3, 1, right, etc. So these 4 each have 2, so there's 8. And then we do the same thing here, so that's also 1. So each of these have the same forward and backwards, so that's 6. And then we have this one, which is a 3, which is 1. And this could be read forwards and backwards. So that is equal to our 4. 2 times 2 is 4 because there's 2 of them and each of them had 2 possibilities. And 4, 4, 4 is 1. And this one is going to be a 2 because there's either 4, 6, 5 or 6, 6, 5, 4, right? And then 5, 5, 5 is only 1. So how many combinations are there when there's only 3 numbers? Well, that's a 4, that's a 9, plus a 9, plus a 7, plus a 5, plus a 3, and plus a 1. So that's a 4, that's a 9, that's a 16, that's a 25, and that's a 29, right? So there's 29 when there's 3 digits. And now we need to find out when it's 4 digits. Okay, so let's start. So the only 4 digits are a 10, 11, and a 12. So for a 10, is there anything possible? Well, we can't add up to a 10. So let's say we have a 10 that goes this way. So we could have let's say 0, 5, 0, 5, and 10. So add to 5 this way, right? 0 plus 5 is 5. 5 plus 5 is 10. So that works. Can we put a 1 here? Well, a 1 If we add a, I don't know, if we add a, like, let's say a 2, that's a 3, doesn't make sense. So 1 to 9, that's a distance of 9, that's not possible. 2 to 8, that's a distance of 4. So divide by distance of 8, so divide by 2 is 4, which is not possible because it goes by 2 here and it goes by 6 here. So after, and then once you do some of these combinations, you find out that only 1050 work. And then we could do 11, and the only one that works for 11 is 1111. And you could check it because you could just say 0, and it would put a 0 here. Let's just say we choose a 5 or something, and then it just doesn't make sense. It's just plus 5 here, but 6 to get to 11. So once you put any, so that tells us that this number has to be an odd. So then this number has to be an even. So then it tells us, let's say this is like a 5. So it goes by a 4, and then it goes by a 6. Okay, so that doesn't work. So let's try a 6. It goes by like a 5, and this goes by a 5, but this is a 6. So you realize that the numbers get way too big, and it doesn't make sense. And then number 12. Is there anything for 12? Well, 1, 2, 3, 4. That's one of them. Can we choose anything else? Well, not really, because this number is too big and it's just like extreme case of 11. So you could logically just think that these are the only combinations left. So then we have 1 here, 1 here, and 1 here. So that's plus a 3. So k is equal to 32. Okay, so we got k, and now we need to get w. So w, if it's a geometric sequence, we could start with 1. So it could be 1, 2, 4, right? Or 1, 1, 1 first because 1 times 1 is 1, 1 times 1 is 1. Or you can go to 2, so 1 times 2 is 2, 2 times 2 is 4. So, or we could go by a 3 was 1, 3, 9, right? And after that, we could have 2, 2, 2, and we could have 2, 4, 8, and then 2, 6, 18, which doesn't work. So right at this point, we stop. And the only ones after that would just be 3, 3, 3, 4, 4, 4, 5, 5, 5. Okay, so that's all that's left for our geometric sequence. And now that's only digits. Now for the 4 digits, we have a 10, 11, and 12, right? So we know that it can't go by 1, 0, so it has to only be a 10. So we could go backwards and we could, let's say, divide by 5, which is 1, which doesn't work, or divide by 1, which gets us another 10, which doesn't work because then we had 3 tens, which is not possible. So we know that 10 doesn't work. And now let's try 11. Well, 11 could be 11, 11, so that works. And we can't do any other numbers because 11 is prime by itself. So we could just have 1, 1, 1, right? So that's technically a geometric sequence. And we have 12. Well, if we divide by 2, that's going to give us a 6, so that's not possible. Divide by, let's say, a 3, that gives us a 4. Then we have to divide by 3, it doesn't work. So we divide by 4, that's a 3, and we can't divide by 4. So we can't divide anything by this number. Or we could just think about it as 1, 2, so next one is 4, and next one is 8. So we have 1. So now we can find out the total amount of combinations because these are all the possibilities. So there's 1 here, there's 2 here. It could be 2, 1, 2, 4, or 4, 2, 1. And there's 2 here, there's 2 here, there's 2 here, and there is 1 here, 1 here, 1 here, 1 here, and 1 here, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Well, 1, 2, 3, 4, 5, 6, 7, 8. Well, sorry, that's just 1. There's only 1 here. Sorry about that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So W is 13. So 32 plus 13, and that is a total of 45. And that is your answer for number 17. So it just takes a long time because it's just one of those that you have to list possibilities. Number 18, determine the sum of all distinct values of x. So basically, and all we have to do is just know some trig identities, which is cosine of x minus sine of x times. And sine of x is just 2 times sine of x times cosine of x. I mean, sine of 2x is equal to 2 times sine of x times cosine of x equals 0. Distribute out a cosine of x. So you get 1 minus sine of x times sine of x, which is, and then there's a 2. So that'll be sine squared of x. That's equals 0. So either cosine of x equals 0 or 1 minus 2 sine squared of x equals 0. So cosine of x equals 0 only when it's at 90 degrees and when it's at 270. And this value is equal to sine of square root of x is equal to 1/2, right? So you just move this to the side and divide by 2. So we could do some quick math. And then that tells us that sine of x, take the square root, would just be square root 2 over 2. So that would mean this is the 45 degrees, but remember, this is sine squared of x. So it's either the positive or negative, it doesn't matter. So it's either going to be at the 45, and then next 45 is going to be at the 135, or the next 45, which is going to be at the 225, and then after that will be 315. So there's 445 degrees. So then find how many threes. Now we just need to add them all together. So 90 plus 270 is 360. 45 plus 315 is 360, and 135 plus 225 is 360. So there's three 360s, and that's a total of 1080 as your answer for number 18. Okay, number 19. In triangle ABC with sides AB and C, A plus B plus C times A plus B minus C equals 3AB, and K equals secant of C, where C is the angle opposite of side C. Determine the value of K. So we know if we distribute it out, we have A squared plus 2AB, and then the negative AC and the positive AC cancel each other out. And then we have a plus b squared, and then the positive bc cancel out with negative bc, and then we have a minus a bc equals 3ab. So it's just the same thing as this equation, but now just distributed. So that gives us that a squared plus b squared minus c squared is equal to 3ab. So that also gives us that c squared, we subtract the 2ab from the 3ab, so we get ab. And then we get c squared is equal to a squared plus b squared um, minus ab, right? So basically, what does this tell us? Well, you need to know a formula, and this is the law of cosine formula. And the law of cosine tells us that c squared is equal to a squared plus b squared minus 2ab times cosine of big C. So we need to find the secant of c. So basically, we know what -1 is equal to the 2 times cosine of c, because that's what the terms kind of simplify out to, right? This is this, this is this, this is this. So this is equal to this, right? And the coefficient is -1. So you can just kind of match it up. So that, and then, this is 1, sorry, coefficient of 1. So then that tells us that cosine of c is equal to 1/2. So to get secant of c, you just need to inverse this, because secant is just equal to 1 over cosine. So basically, we just need to inverse 1/2, reciprocal 1/2, which gets us 2. And that is the value of our k. And that's basically it. You just need to know the formula for law of cosine. Well, that covers number 17, 18, and 19. Thanks for watching, and I'll see you at the next math record.